Oh, that's more people than I expected. Wow. Uh, so, hello everyone. Welcome to my talk about the Ubuntu Touch, the alternative operating system for your smartphones. So first of all, this is the first time I'm doing the talk at this scale, so I'm a little bit exciting and also I've been getting a little bit busier in the coming weeks before this event, so the slide might be a little bit less polished. So apologize for that. Uh, so first of all, my name is Rachanan, and I've been involved in the Ubuntu Touch community since around 2015 and has since become the Ubuntu Touch maintainer and developer. And other than that, I've been interested in web development, system administration, and software licensing also. So, uh, in this talk, I'm going to talk about what is Ubuntu Touch and why you might be interested in it. And then I'll talk a little bit about history of Ubuntu Touch and UBports community, which now maintain Ubuntu Touch. And then I'll dive into the architecture of the Ubuntu Touch, the important components inside it, and how Ubuntu Touch can reuse Android drivers, which is one of the unique features of us which allow us to run on many phones. And finally, I'll broaden the horizon a little bit and talk about other Linux-based mobile OS similar to us, since we are not the only OS in the town. Let's say that. Right. Uh, let's start with what is Ubuntu Touch. So Ubuntu Touch is a Linux mobile operating system for smartphones. Now, I would like to talk that Ubuntu Touch is not another fork of Android or the Googled Android or something like that. We are, this is its own operating system which is based on popular Ubuntu OS. And our code is open source and respects your privacy, which I heard is important for some of you guys. We and today, Ubuntu Touch is maintained by UBports community, which is the community of users and developers around the world. And I will talk about that shortly after this. Okay. So the features of Ubuntu Touch, including that we are ready for daily driving. We have all the basic functionalities ready, including the calling, the SMAs, the camera, web browsing, and also like email and and then we have the convergence, which is the ability to dock your smartphone to your screen, keyboard, and mouse, and then you can work it like this is your computer. Ubuntu Touch is lightweight, which means it's usable even on older devices. This translates to a longer up-to-date software for that device, which prolongs its usefulness, right? And then it can run many Android applications. For those that are still depending on it, we have a compatibility layer which allows Ubuntu Touch to run Android applications. And then we have no tracking or phoning home. Now that's not strictly true because we does have like the modern smartphone creature comforts such as push notification and system image updating. I mean system updating. But basically we don't intentionally collect information to sell off or well to use that information for advertising. And also we don't have remote locking capability, so us or device manufacturer cannot lock the device down to force you to, for example, pay off your mobile phone bill or something like that. So let's talk about the history of Ubuntu Touch. Ubuntu Touch is created by Canonical in 2013 as part of their Ubuntu Everywhere vision. Like you might have remembered when the time when Canonical tried to put Ubuntu everywhere in your TVs, in your laptops, in your tablets, and in your phones. They have a preview in 2013, and then they have a release in 2014. And after that, they tried to create the phones themselves and create a Kickstarter campaign to kickstart that. It did not end well. So you might have remembered Ubuntu 8, right? So it did not end well. So we then so they instead negotiate with phone manufacturers, which is BQ and Meizu. They are phone manufacturers in Europe, so you might have not heard them. But basically, they got a few phones and tablets out with Ubuntu Touch pre-installed. But then, like a few years later, in 2017, they realized they are not very successful, and so they abandoned the project. So luckily for Ubuntu Touch, the UB Pros community has stepped up and adopted the Ubuntu Touch project and maintained it to this day. So now let's talk about UBports itself a little bit. So UBports is started in 2015 by Mr. Mares Gripsgaard. He's from Norway and he is very talented. So initially UBports started on porting to devices, which is the act of making Ubuntu Touch run on many Android devices and make it suit that particular device. But then as Ubuntu Touch abandoned by Canonical, UBports project, UBports community adopt the project from Canonical, and then we have founded the UBports Foundation to support the project and the development. Nowadays, UBports is a diverse community, and while what? Oh, okay. And while UBports is primarily European, we have members from USA, from Pakistan, India, and I myself am from Thailand. So the community is quite diverse, I would say. But enough of the history lessons. Let's get into the architecture of Ubuntu Touch. Right. So yeah, first of all, apologies for a little bit of small image because we have quite a bit of details in this image. So on the top we have the applications running, and these applications are confined, uh, like they have its own sandbox similar to Android. And then we have a number of middlewares below that to support the applications. Some of the middlewares are those that you might be familiar from Ubuntu desktop, like Dbus, systemd, network manager, and then we have some of the Ubuntu Touch specific middlewares, and I will discuss about that after this. And then beneath those middlewares, we have a minimal Android container, which runs the core components of Android plus the Android house hardware abstraction layers. And this allows us to reuse the Android drivers and run on a large number of Android-based devices. And this is one of the unique features of us. And then below that, we have the Android-based kernels. But if Ubuntu Touch is running on top of mainline-based phones, then this Android container won't be needed, and the middlewares can talk to the kernel directly. So now let's discuss about some important hmm, some of the components in this diagram in more detail. So let's start with Lomery. So the Lomery is basically a display server. It borns together with Ubuntu Touch itself, and is formerly known as Unity 8, as some of you might have remembered. Lomery use Mir as a display server layer and use Qt for its UI. And some of you might have remembered and Mir has a reputation of being its own thing with its own protocol, competing with Wayland, all that stuff. However, nowadays, Mir is now Wayland system, a Wayland compositor, and is still maintained by Canonical to this day because they find its own use cases, and so they find it worth maintaining. So we benefit from that. One of the unique features of Lomari is that it can morph between phones, tablet, and desktop, and they can do so while leaving all the applications running, similar to Samsung DeX and Windows Phone's Continuum back in the day. So that allows us to have the convergence feature of the phone. Now we have a number of middlewares supporting the applications and the shell itself. Some of you will have heard like Qt and Network Manager, GStreamer, and Pulse Radio. But then we have some of our own middlewares that you probably won't see much on Ubuntu desktop or desktop Linux, such as Ophono, which is the modem manager. And then we have sensor FW, which allows you to access accelerometers and sensors like that. And then we have something called Qt Ubuntu Camera, which allows applications to access camera using Android drivers. And same goes for HFD service, which allows applications to access haptic feedback devices. Now, for the middlewares that we shared with desktops Linux, we also have some of our own modifications to make them work better on Ubuntu Touch. For example, on Qt, we have our own platform abstractions plugged in to make Qt applications work with Ubuntu with mere display server uh, with our own media playback pipeline and content sharing. And then with Network Manager, we have modifications for them to work well with Ophono, our modem manager, instead of the more commonly used modem manager on desktop Linux and some other mobile OS distribution. And then on GStreamer, we have a plugin which allows applications to connect to Android's hardware acceleration layer, and same goes for Pulse Audio, which we have a plugin for accessing audio hardwares. Uh, Now, all these middlewares, we need a way. They need a way to communicate with Android container and Android drivers inside. So let's talk about some of the techniques that we use to connect to them. We start with libgbinder, which is a library that implements the binder IPC protocols, and they use glib, this which allows Linux process to communicate to on the Android containers, all the services inside the Android container. Uh, lib libgbinder supports both AIDL and HIDL protocol, which means that libgbinder can also be used to talk to so-called binderized HALs that starts in Android 8 with Project Treble and all that stuff. However, it does not yet support the definition, the interface definition language, which means that applications that use libgbinder have to specify the constants manually, which means that libgbinder is limited to less complex stuff, such as controlling the modem and something like that. For the more complex things, we have another technique which we called libhybris. So libhybris basically is a modified copy of Bionic's dynamic loader. So Bionic is Android C library, by the way. So when it loads an Android library, it contains the hooked functions which will interpose the calls to Bionic libc and make and have its own implementation that calls into host libc instead. So this allows Android library to coexist in the same process as ordinary Linux process. This is so the somewhat complex interactions with Android services and C++ code can be written in as just a Android library, and then we can use DLSIM and DLOpen and DLSIM to load the C APIs that library expose. So this is also used by for the in so-called in-process house such as libegl and libgles to provide hardware accelerated graphical rendering for applications. Now let's talk a little bit about the Ubuntu Touch security model. So each application is packaged in its own container called Click, which is Canonical Snap's precursor. The application is confined using AppArmor, which prevents access to users' data by default. So for app to request access to other applications' data or users' data, they have to do so via a middleman, which is called Content Hub. This is not yet XDG desktop portal stuff because this predates that project. So we have a plan to migrate to XDG desktop portal in the future, but for now we have this own custom thing. And for applications to access certain hardware such as camera or microphone, we have a permission prompt in place similar to Android to make sure that users are aware which applications have this sort of hardware access. So now let's zoom out of Ubuntu Touch itself a little bit and talk about wider landscape of Linux-based mobile operating system. Now Ubuntu Touch is obviously not the only player in this field. Several other distributions are also providing their own versions of mobile OS. We can divide OSs in this slide into two groups. The first two on the left is those that have the same technique as us and run and allows running Android container below to allow accessing Android drivers, which are the Selfish OS and the Droidian. And especially for Selfish OS, they maintained quite a number of techniques that we use and a lot of middleware such as libgbinder, libhybrids, and sensorfw that are mentioned earlier. So we are very grateful to them. And the other four on the right, which are Mobian PureOS, Postmarket OS, and Manjaro ARM. These are more focused on mainline-based phones such as Pine phones and Librem 5 and Purism. And these phones run like mainline-based kernel and have uh, like normal Linux kernel interface to the hardware, which allows them to be essentially blob-free. And this, but this means there's less non-free code inside their phone, like including their like like Android drivers are from vendors are usually not free, right? But this means that these OSs can also support less phone, and each phone will have to be supported in the kernel itself before this operating system can be used on them. And this is the choices that user can make in the depending on their ideology. And this is important because this is the choices that we can provide to all users instead of Google, Apple duopoly that we have today. So this is the reason I bring up this slide and talk about other OSs too, because at Ubuntu Touch, what we believe is the freedom of choices. the freedom that you can choose uh, whatever OS you use, whoever you want to share information with, and the privacy to have information not shared with other people that we are not sharing. We don't want to to share them with, and this is the reason that we still maintain the Ubuntu Touch today, to provide you as an alternative choice for your smartphones, to have phones in the way exactly the way you want, and to have freedom and to have privacy, which is the basic right of all human. So that's it for today. And if you want to learn more, you can visit our website at ubports.com and ubuntutouch.io. We also have a Telegram group that can welcome everyone, can that welcome everyone to discuss about the Ubuntu Touch. As for me, I'm available as Pete-PSUWIT on GitLab, GitHub, and X. And if you are interested in more, we have demos and stickers and leaflets available at the Ubuntu TW booth at the TR312 room. So yeah, so that's it for today. Thank you everyone, and it's now time for questions.
Do we have any questions from the audience?
Yes, thank you for sharing. So I have one question about the packages. Ubuntu Touch is using the Click packages,
Yes.
and now the Ubuntu community has been moving from Click to Snap. I'm wondering so far, is UBPO community maintaining the server for Click packages, and how many active Click has been provided by community?
Right. So admittedly, Click is now Ubuntu Touch specific format, right? We have our own server and application storefront for Click applications called Open Store, and right now, okay, admittedly we have the applications in the hundreds, so not that much, but enough for many people to actually daily drive Ubuntu Touch. We are also experimenting with Snap package to allow them to be used in the Ubuntu Touch, and this will actually realize and it fits very well with convergence, right? Because you can now run like actual desktop application on the Ubuntu Touch itself without resorting to other containerization technique, and like you have actual desktop application running. We also have a demo of that at our booth, and we are happy to talk about it more.
Any more questions?
What's the best hardware to try it on?
The best hardware, that's actually Fairphone and Volaphone, but I recognize that that's probably not available in Taiwan. So we have a list of devices available at devices.ubuntutouch.io. I can show you this. And like these are the list of devices that are supported in the current version of Ubuntu Touch. For those that in Taiwan, you probably will be interested in the Redmi and Xiaomi phones. And for those that come from Europe, you will probably want to look at Fairphone for FN and Volaphone. And actually, Volaphone sells Ubuntu Touch pre-installed, which is actually another manufacturers from, like, apart from those in canonical days, and the way they supported Ubuntu Touch development a lot. So shout out to them and thank you them for supporting our project.
Okay, any more questions? So, I'll ask one myself then. I wasn't aware of the techniques you guys use to use Android code for hardware support. How well does it work in practice?
Uh, it works well enough for us. However, it's kind of not exactly mouse catching game, but like for a lack of better word, because Android changes and evolves a lot underneath. Like on top of on top layer that applications use, they are pretty stable. However, underneath, like they changed a lot. Like recently in Android 11, I think they changed the protocol underneath that talks between binderized house and framework from the HIDL to AIDL again. And that means catch up work for us to develop on top of the new protocol. Like we don't even currently properly support Android phones that have like newer vendor partition. Like if your vendor partition is based on Android 13 or 14, we are currently screwed. However, luckily, because of a thing called Google requirement freeze, some devices are shipped with like Android 14 but have like Android 12 vendor partition underneath, like Fairphone 5, if you have heard the news about that, which means that we can still support newer phones for a few years. But eventually we will have to support newer Android version and newer vendor partitions too.
So Android maintains good compatibility for apps, but not at the layers that you're using for hardware enablement.
Yeah,
Right.
for hardware, like they have compatibility for apps, right? But like for hardware vendors, it changed a lot. Like I imagine that it would be quite a bit of chore too for hardware manufacturers, but it's even more so for small community like us.
Got it. Okay, final call for questions.
I'm interested since you are kind of like reusing certain parts of the Android graphics binary libraries.
Yes,
So how does it like kind of integrate into, for example, like the GBM framework or other Mesa
it does
projects?
not.
They don't. So how do you like, how does your compositor work with the, is your compositor only working with the Android graphic libraries?
So the Mir system, they are pluggable. So we are integrated in that layer. So Mir have a pluggable layer, the pluggable backend, and we have our own backend, which is developed by Canonical, by the way. So the backend talks to the Android specific code via libhybris because graphical stuff is something you have to load into the process. And then for the applications, they also load libegl and libgles via the small wrapper that libhybris provide. And so they both load Android graphical libraries into the process and do hardware acceleration that way.
So the system compositor, which typically runs outside of any containers, uses libhybris to talk to the Android graphics stack. And
Yes,
apps also use libhybris.
yes.
Okay, any more questions? If not, let's thank the speaker.
Yes. Please go to TR312. We have all demos.
Impressive project, keeping this stuff alive.
Thank you. Uh, was better than I expected.
Here you see?
我叫 Scott。
Scott 哦，好像有听过
你。的笔电有 HDMI？
有 HDMI 跟 DP 可以吗？你们 HDMI 好。45分嘛，对，好，我去上个厕所。
那现在应该会是一个哦，有些没人问，你的荧幕就开了。
好，为什么点不出来？有那么多 slide。我们在等那个 Scott 回来。
这里面是可以这样寄出来的吗？
哎，你想到好问题。
应该不行吧？
啊，寄出来啊、